So, have you ever looked at these massive cloud platforms and wondered how on earth do they manage all of that without an army of people clicking buttons all day? Well, you've come to the right place. Today, we're going to talk about Terraform, a tool that's an absolute game changer for anyone in cloud or DevOps. It lets you build and manage your entire cloud with, you guessed it, code. Let's get into it. All right, here's our game plan. We'll start with the big idea behind Terraform. Then we'll talk about why we even need a tool like this, the problem it solves. After that, we'll break down exactly how it works. Then we'll see where it fits in the real world of automation. And finally, we'll wrap up with the pros and cons you got to keep in mind. Okay, so first things first. Before we can really get what Terraform is, we have to talk about the concept it's built on, which is this really powerful idea called infrastructure as code. So, what is infrastructure as code, or IAC? Well, it's pretty much what it sounds like. Instead of manually clicking around in a web console to set up your servers, your networks, your databases, you define all of it in files, in code. This means your entire cloud setup can be versioned, reviewed, and tested, just like any other piece of software. It's all about making it repeatable and predictable. And that is exactly where Terraform enters the picture. It's this super popular open source tool from a company called HashiCorp, and it's designed to make infrastructure as code a reality. It's basically the language you use to tell the cloud, hey, this is what I want you to build. But you might be thinking, why bother with all this code? I can just click around and get a server running. And you're right, you can. But when you start doing that at scale, you run into some pretty serious problems. And this slide just lays it all out, right? On the left, you've got the old manual way. We've all been there. It's so easy to make a mistake, a little typo, and suddenly your test environment is slightly different from your production one. And forget trying to scale that. It's a total nightmare. Plus, who remembers what changed last Tuesday? Nobody. Now, look at the right, the code way. It's automated, so it's consistent every single time. Scaling is a piece of cake. And every change, it's tracked in Git. You know who changed what, when, and why. It's really about moving from chaos to control. So how does Terraform actually pull this off? Well, its power really comes from this simple, super predictable three-step workflow. It all starts with write. You define what you want in a special language called HCL, which is designed to be really easy for humans to read. Then comes the most important safety step, plan. You run a command, Terraform plan, and it gives you a preview. It tells you, hey, here is exactly what I'm about to create, change, or even destroy. No surprises. Once you look at that plan and say, yep, that's what I want, you move to the final step, apply. You run Terraform apply, and Terraform goes out and makes it happen. But wait, how does Terraform know what needs to change during that plan step? The secret sauce is something called the state file. Think of this file as Terraform's brain, or its memory. It keeps a perfect map of all the infrastructure it's already built. So when you run plan, it compares your new code to what's in the state file and figures out the exact difference. It's the source of truth. And the cool thing is, Terraform isn't just for one cloud. It can talk to pretty much anything using things called providers. A provider is basically a plugin, like a translator. You write your code once to ask for a server, and then the AWS provider translates that for Amazon's cloud. The Azure provider translates it for Microsoft's cloud, and so on. It's incredibly flexible. So, what are you actually writing in that HCL code? You're defining resources. These are the Lego bricks of your infrastructure. A virtual machine is a resource. A network is a resource. A database is a resource. Each provider gives you a whole library of resources that you can use to build whatever you need. Now, as your setup gets more complex, you don't want to be copying and pasting the same 20 lines of code over and over again. That's where modules come in. A module is just a reusable chunk of Terraform code. You can package up a common setup, like a web server with its networking and security, into a module. Then you can reuse that module with a single line of code. It's all about staying organized and not repeating yourself. Okay, so let's zoom out a little bit. We've talked about the code, the plan, and the resources, but how does this all fit into the bigger picture of modern software development? Well, in the world of DevOps, automation is everything, and this is where Terraform really shines. When you look at a CI/CD pipeline, that automated process that takes code from a developer's laptop to production, Terraform plays a vital role. It's what you use to automatically create the infrastructure for each stage. It spins up identical environments for development, testing, and production. This completely gets rid of that old, well, it worked on my machine problem. The result? Deployments become way faster and a whole lot more reliable. Just picture this for a second. A developer pushes some new code that needs, let's say, a new database. The pipeline kicks off, and as one of the first steps, it automatically runs Terraform apply. Terraform creates that new database exactly as it's defined in the code. Then the pipeline deploys the new application code. The whole system, both the infrastructure and the app, gets updated from a single Git push. That's the power of this. Now, look, Terraform is an amazing tool. It's incredibly powerful. But like any powerful tool, you gotta know what you're getting into. It's important to understand both its incredible strengths and the things you really need to be mindful of. The advantages are pretty clear, right? It works with pretty much any cloud you can think of. It's built from the ground up for automation. You get all the benefits of version control through Git, and modules make your code clean and reusable. Now, on the other side, I wouldn't call these disadvantages. They're more like responsibilities. You absolutely have to manage that state file carefully. There's a bit of a learning curve for the HCL language. And you always have to remember, with great power comes great responsibility. A mistake in your code can definitely have a real impact on your live system. So, if we were to boil it all down, what's the key takeaway? It's this. Terraform is a foundational tool for anyone building in the cloud today. It allows you to automate and manage your infrastructure with incredible efficiency, and that directly leads to systems that are more scalable, more reliable, and just perfectly consistent every time. Ultimately, making that shift from clicking buttons in a console to writing declarative code, it just unlocks a whole new universe of speed and control. So the real question I want to leave you with is this. Is your infrastructure ready to be written in code?